Another method for solving quadratic equations is something called completing the square. Now this is the longest of all the methods for solving quadratic equations, so generally we don't do this method unless we're told to do this method. So I already have our steps over here, but let's go ahead and just put up an example and see how it works out. So let's say that we have a quadratic equation like 2x squared plus 8x, minus 14 is equal to 0. If we were just told to solve, and that was our only directions, we would want to go through our process for solving quadratic equations, which means first thing we want to try to do is extract the root, which we can't because of that 8x. The next thing we'd want to try to do is factor, which this won't factor. Then we'd actually use our quadratic formula, which would be our last resort. However, completing the square is a skill that we're going to need in future courses, so we do need to learn how to do it. So generally the directions here would say solve by completing the square. So let's see how it works. Step 1 says divide through by the lead coefficient. It only works if our lead coefficient is a 1, so let's divide everything here by 2. So I'm going to get x squared plus 4x minus 7 is equal to 0. Next step says move the constant to the other side. So let's move that 7 to the other side. Now here's where this method gets its name from completing the square. So what we're going to do is, after the linear term, we're going to write another square term on that side. And of course, whatever we do to one side, we have to do to the other. Now here's the idea. Here's what we're aiming for. I want this thing on this side to factor, and I want it to factor to a perfect square binomial. I want it to factor to just two pieces being squared. How can I force that to happen? Well, by using one of the two formulas that we've seen in the past, plus 2ab plus b squared factors to a plus or minus b squared, right? If something has this form, then we know we can factor it into a binomial squared. Well, we already have two pieces. We need to decide what the third piece needs to be. What does that need to be so it'll factor? Well, notice in our formula here, our a is an x. So what we have right now, we have, and since this one's a plus, I'm just going to go with plus. Here we have x squared. Now remember the a is the x, so we have 2xb plus b squared. We're trying to figure out what b needs to be. Well, we see right here in front of the x, right, remember here, technically in front of this x, there's a 2b. We have a 2b in front of the x, and over there, there's a 4. So we know that 2b has to be where it's in front of the x. So b is half, and it's always going to be half. B is always half of whatever that number right there is, because that's 2b from the formula. So let me go ahead and erase this real quick. So half of the linear coefficient would be 2. That's what you put in these parentheses. Now, the reason we do this is now this factors, and we know it factors because we made it factor using our perfect square trinomials here. This factors to x plus 2 squared. Now, on the other side, we just got to work out what those numbers are. So we have x plus 2 is equal to, what's that going to be, 11. All right, now this is the reason we did this entire method. The reason we did all this work is because now we have something squared and everything else is numbers, which means we can extract the root here. So I'm going to go ahead and bring this to the top so we got a little bit more room. I'm going to take the square root of both sides. So I have x plus 2 is equal to plus or minus square root of 11. Anytime you put a radical into a problem, you want to simplify it immediately, and well, we can't simplify that anymore. Finish solving here, so we get x is equal to negative 2 plus or minus the square root of 11. All right, so this was a quadratic. We were expecting two answers, and there's our two answers, right? Negative 2 plus the square root of 11, negative 2 minus the square root of 11. All right, so the entire idea for completing the square is get us into a situation to where we can force it to be factored into a binomial squared so we can extract the root. All right, let's take a look at another example. Let me go and get this out of here. Get a little bit more room. Okay, let's say we have 3x squared plus 4x minus 6 is equal to 0. This will be a little bit more messy. All right, so here we were told to solve by completing the square. So following our steps, first step we want to divide everything by our lead coefficient. So I get x squared plus 4/3 x minus 2 is equal to 0. Next step says move all the numbers to the other side. So x squared plus 4/3 x equals 2. Now the next step, I know I'm going to add something squared to both sides. So go ahead and write that in there. Now we just got to figure out what goes inside the parentheses. Well, that's half of our linear coefficient. So half of 4/3. Now if you got fractions, remember, what's the sentence I just said? Half of 4/3. Remember, of in math means multiply. So when we multiply fractions, we can multiply straight across. Now we can reduce first if you want to. But notice if you multiply straight across the top, we get 4/6, which reduces to 2/3. All right, so we put 2/3 into our parentheses here, 2/3 and 2/3. Now I know it looks ugly, but we know how this left side factors because we made it work out like this. So over here, this factors to x plus 2/3 squared. Now on the right hand side, we do need to work out what those numbers are. So let me come this way and just do a little bit of arithmetic. So 2 plus 4, what's a 4? 4/9. Well, we need a common denominator, which is 9. So 18/9 plus 4/9 would be 22/9. So we got x plus 2/3 squared is equal to 22/9. All right, now we have something squared and everything else is numbers, so we can extract the root. So again, I'm going to bring this up to the top. So x plus 2/3 squared is equal to what I say, 22/9. Yep. So we're going to take the square root of both sides. That gets rid of our squared power. And we got to do plus or minus the square root of the other side. Now, as soon as you put a radical into a problem, you want to simplify it. Now, I can't simplify 22/9 when we do the root of a fraction. We're going to do the root of the top over the root of the bottom. In simplifying each one of those, I can't think of any perfect squares in 22, so that stays the square root of 22, but the square root of 9 is 3. Now we have to do a solve to just move the 2/3 to the other side, so subtract 2/3. So we get x is negative 2/3 plus or minus square root of 22/3. Now that's a perfectly fine answer, but since these already have a common denominator, we could actually write it as negative 2 plus or minus the square root of 22 all over 3. So either one of those would be a perfectly fine answer. So extracting the root, a very important skill that we're going to need in the future, but overall not necessarily the best way to solve a quadratic equation. Actually, our final method for solving a quadratic equation is called the quadratic formula. Now, if we start out with a quadratic equation that looks like this, ax squared plus bx plus c is equal to 0, and we were to complete the square exactly like what we did over here. Now, it'd be messy because we don't have numbers. We'd have these a, b's, and c's. We could actually get to our quadratic formula. So here, if we complete the square now for time's sake, I'm not going to do it in this video, maybe a future video. If we complete the square, what we end up with is x is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. This is our quadratic formula. This is incredibly important. The reason that this is so important is because here's a formula that will solve every single quadratic in the entire universe. All you got to do is make sure you start out with your quadratic in this form, plug the numbers into here, and simplify, and you're done. All right, so let's see how this works. I'm actually going to come over here now. Now that we've seen all of our methods, we haven't seen an example of this. we've kind of talked about these as we've gone through, but now that we've seen all our methods, anytime you see a quadratic, here's what you're going to want to do. You're always going to want to try to extract the root. However, we saw that you can't always do that. The next thing you're going to want to try is factoring. Unfortunately, you can't always do that. But here's the good news. The quadratic formula always works. Now, you're going to want to try to do these first because they're much quicker and easier than this, but good news is that always works. Now, we did see a fourth method. Completing the square. Now, notice I put a line there because since the quadratic formula works for every single quadratic, you'd actually never make it here. Unless you're told to complete the square, most people don't treat that as a solution method. All right, let's just try a couple of these because it's really just plugging it into the formula. So let's start out with okay, so let's go through. This is a quadratic equation, so the first thing we try to do is extract the root. We can't do that. The next thing we try to do is factor. Now this won't factor, but think back. Remember what our steps for factoring were. Our first step for trying to factor something is clear grouping symbols and then move everything to one side. Now in this case, that's already done for this problem. But notice the first two steps in factoring, you need to do anyway for the first step for the quadratic equation. It has to be in that form. So these just kind of flow one right into each other. So once you clear your grouping symbols and move everything to one side to see if it'll factor, then it's in the right form to try the quadratic formula. Now here's what I would suggest, especially when you're first starting out. Underneath this, once you have everything on one side and you know it won't factor, state what A, B, and C are. In this case, A is 2, B is -3, C is 5. Then right underneath that, go ahead and write down the quadratic formula every single time. It's easier to plug into a formula when you're looking at it, and it's going to help you memorize it if you write it down every time. All right, so I'm going to take this, and everywhere that there's a letter, I'm going to put parentheses, because that's what I'm going to be plugging in. So b squared minus 4ac, all divided by 2a. All right, so let's see. Everywhere there's an A, I put a 2. Everywhere there's a B, I put a -3. And everywhere there's a C, I put a 5. Okay, now you want to do is simplify all the numbers that you can. So we do have a bit of arithmetic to do. So negative becomes a +3. That's going to be 9 minus, let's see, 4 times 2 times 5 would be 40. All over 4. We're still not quite done simplifying our numbers. So we get x is equal to 3 plus or minus the square root of negative, what's that going to be, 31? All over 4. Now once you've simplified all the numbers, then see if you can simplify your radical. Now in this case, we can simplify the radical a little bit. That's, we can take out the I, all over 4. Now the last thing you want to try to do is see if you can simplify this fraction. We'll see on the next example what I mean by that, but that's it. So all you're going to do is plug in your numbers. So if you want to, there you go. There we go. Simplify the numbers. Simplify the radical. And then the last step that we didn't end up doing here is simplify the fraction. All right, so not really steps, because really we're just simplifying an expression here, but you're always just going to plug in your numbers, simplify all those numbers, simplify the radical, and the last step, which again we didn't have to do on this one, was simplify the fraction. All right, let's take a look at another one of these, because again, we're really just plugging numbers into a formula here. So I guess I can come back over here and get us started. So let's say we have Okay, so here is our equation. Now this is a quadratic equation because, well, it's a polynomial whose highest power is 2. We'd want to follow our steps. The first thing we want to do is extract the root. We can't do that because of the 4x. Next thing we want to do is factor. So clear all our grouping symbols, move everything to one side. That's done. Try to factor. This won't factor. So since it won't factor, we're automatically just going to do the quadratic formula. Again, we want to stay with A, B, and C are. And then we're going to plug it into our quadratic formula. B squared minus 4AC all over 2A. Okay, so plugging in, again, make sure you use parentheses here. Easiest way to do it, parentheses squared, 4 parentheses, parentheses, 2 parentheses. All right, everywhere there's an A, I put a 1. Everywhere there's a B, I put a -4. Everywhere there's a C, I put a 7. Okay, let's see what this ends up being. So it's going to be 4 plus or minus square root of 16 minus, what's that, 28 all over 2. Okay, so we still need to simplify our numbers a little bit. So we get, moving it up here just for a little bit more room, we get x is equal to 4 plus or minus the square root, let's see, 16 minus 28 is what, 12? Minus 12 all over 2. Okay, now that we've simplified the numbers, we want to simplify the radical. So that radical will simplify quite a bit. Let's see, I know that there's a negative in there, so I'm going to get an I. And I know 12 is equal to 3 times 4. So the perfect square in 12 is 4, so the square root of 4 is 2, square root of 3 all over 2. Okay, so I simplified my radical. The last step, which we didn't have on the last one, is simplify the fraction. So to simplify the fraction, you look for a greatest common factor on the top. Now notice over here, we did not have a greatest common factor, but here we do. Each one of those two things on the top has a factor of 2. If I factor a 2 out of the top, I can now reduce in this case. Sometimes you can factor it out and it won't reduce. But in this case, since it factored out, we can reduce. So we get x is 2 plus or minus I square roots of 3. All right, so there's our two answers, 2 plus I square roots of 3 and 2 minus I square roots of 3. The good news when we're using the quadratic formula, it'll always work, but it does take a little bit of arithmetic to be able to get to our answer. So you should now be able to solve any quadratic equation that you run into, and you want to follow your steps going down from the easiest to the hardest method. Now don't forget learning how to complete the square because it is a skill that we're going to need in the future.